right, matrix or matrices. Matrix is the singular form. Matrices, that's your plural. A matrix is just a way to organize information. Okay, it's just a way to organize information into rows and columns. So just make sure. And when we talk about information, we're obviously generally talking about numbers. Okay, prices. Okay, like if you're looking at how, like if you own a store and you're looking at how much each individual thing costs and all that kind of stuff, you could organize that into a matrix, into rows and columns. All right, now it's very important to understand the difference between rows and columns, because everything that we do with matrices are based on rows and columns. All right, everything that we worry about as far as adding, subtracting, and multiplying is going to be based on rows and columns. You got to understand how rows and columns work. Okay, the rows and the columns. The rows go left to right. Okay, so in school, especially, we talk about sitting in rows. All right, that's actually incorrect. Technically, you sit in columns. Okay, rows run from left to right. Okay, so you need to make sure you understand rows are from left to right, and columns are up and down. So when you organize matrices, okay, we're always putting them into rows and columns. All right. You need to understand rows left to right, columns up and down. All right, matrices are basically given a letter name. So, for example, would be like matrix A, matrix B, matrix C, so on and so forth. Okay, so we talk about matrices, and they're always capital letters. All right, so because we're going to distinguish, a capital letter means the entire matrix. And here in a minute, we'll talk about the elements. Elements are lowercase letters. So, like uppercase A would be matrix A, lowercase a would be part of matrix A. Okay, so it's a lowercase. Dimensions are the number of rows and columns in that order. You will never have a matrix that you go column by row. It's always row by column. All right, and so depending on the number, all right. And for an example, what that would look like would, if I had a 2 by 2 matrix. Okay, let's say I had a 2 by 2 matrix. A 2 by 2 matrix would mean 2 rows and 2 columns. Okay, 2 rows and 2 columns. And this is the dimensions. Like, you can't add or subtract unless you know the dimensions. You can't multiply, because there's very specific rules about these dimensions that you have to know in order to be able to add, subtract, multiply, and all that kind of stuff. Okay, so you need to make sure dimensions are always the number of rows by the number of columns. Okay, the number of rows by the number of columns. So 2 by 2 would have 2 rows and 2 columns. A 2 by 3 would have 2 rows, 3 columns. A 3 by 1, 3 rows, 1 column, so on and so forth. Okay. All right, let's talk about matrix elements. All right, elements are the individual pieces. So each individual number, or whatever's inside your matrix, could be letters. Anything inside of your matrix, each little individual piece, okay, is called an element. All right. And elements are basically, they're given, so they are the lowercase letter of whatever your matrix is. So we said we're going to name matrices by uppercase letters, so like capital A, capital B, capital C. Well, the individual elements are named for the lowercase letter of that. Okay. So if you had an uppercase matrix A, the elements would all be lowercase a's. Okay? So elements have lowercase letter of the given matrix. So let's say I have matrix A. Alright? And let's say matrix A is a 2 by 2. Alright? Matrix A is a 2 by 2. So if I have 2 by 2, that means I have 2 rows and 2 columns, right? So 2 rows and 2 columns. Alright? That would be matrix A. Now, if I know it's a 2 by 2, how many elements am I going to have in this matrix? 4, right? Because it's a 2 by 2. Because you got 1, 2, 3, 4. You got 4 elements in a 2 by 2 matrix. Everybody got that? Okay, so, alright, so this matrix, this element right here would be the first element, alright? So it'd be lowercase a. Now, we also individualize these elements by their position in the matrix. So, if this is in the first row, first column, it would be lowercase a, 1, 1. Alright, so let's kind of look at that. A1, 1 means it is the element in the first row and first column. Notice how it's always row by column. That is a major theme with matrices. It's always row by column. So A11, first row, first column, whatever element that is. Okay, that could be more often than not, it's going to be a letter or a number. So what would the next one be? This one would be lowercase a, because we're still in matrix A. All of them are going to have lowercase a. But to determine what lowercase a is, what its true position is, we have to figure out what row and column it's in. So have we moved out of the first row? No, because remember, rows go left to right. So we're still in this first row, right? All right, so we're in the first row, but what column are we in? We're in the second column, so that would be A, 1, 2. Okay? Everybody got me? All right, so now if I come down here, if I move down 1, so now we're coming off the first row. So it would be A, 2, and then what column are we in? First, right? And then our last element would be A, 2, 2, because we're in the second row, second column. Now, to me, it's pretty simple because notice how the first numbers are the same. So if you get this first one, it sets the rest of it up because the first numbers for all of these should be the same. If we had 10 columns, all of these in the first one would have the same first number because they're all in the first row. Okay, it's also in the first column. So if we came 10 down this way, came 10 down in this column, as long as I know the second number, okay, would be the same in that column. All right, so just make sure you understand that because just very simple questions. It'd be very easy to give this a little minor assessment to where we look at it and we say, okay, what is element A23? So you go to your matrix, you got to figure out, well, what's in the second row, third column, right? What number is that? Okay, very simple stuff as far as that goes. All right, any questions about how the matrix is set up? Now, obviously, that would extend to whatever, okay? All right, so what I want you to do, all right, so we're going to have matrix B, all right, matrix B, and matrix B is going to be a 2 by 3. I want you to fill it in with the elements, okay? I want you to fill it in with the elements. So we're talking matrix B, so what letter we're going to use is going to be lowercase b, right? And I want you to fill in a 2 by 3, okay? I want you to fill in a 2 by 3. Make sure you're understanding the difference between rows and columns. Alright, would this be the correct representation of a 2 by 3? No. Okay. This would not be how you set up a 2 by 3. And why is that? That'd be how many rows? That'd be 3 rows. That'd be a 3 by 2. Okay? Remember, rows run this way. Okay? Rows run this way. Now, to me, the easiest way to determine the dimensions to know if I have it right, okay, and this kind of goes backwards because we know the rows run left and right, and we know the columns run up and down. But if you want to, to me, the easiest way to count them is to count this way and this way to get the dimensions. Start at the bottom and count up. That's how many rows, and then go across, and that'll tell you how many columns you got because of the way they run. Now, that really only works if you start down here and work your way up and across. Okay. But here, if I were to count, that'd be 1, 2, 3, right? 1, 2. So I would say that's a 3 by 2, which is not what we're looking for, right? We're looking for a 2 by 3. So if you want to set up a 2 by 3 correctly, then you should have 1, 2, 3, 1, 2, 3, right? Now we have 1, 2 rows, 1, 2, 3 columns. Now I have my 2 by 3. All right, and then from there, we should have B, 1, 1. Right? B1, 2, B1, 3, because they're all in the first row, so they have different columns. Then we are B2, 1, right? B2, 2, and B2, 3, right? One thing you should always know, your last element should always match the dimensions. Should always match the dimensions if you're doing it correctly. Okay, so if you got here and you didn't have 2, 3, okay, we would know that I filled that out incorrectly, if miscounted, had done something. Okay, because that kind of tells you right there. All right, is everybody okay with kind of filling that in? Everybody good? All right, now let's take a look at what we're really going to be looking at as far as matrix. Let's say I have a matrix A. Really basic here. So this is what a matrix would look like. Now, we said it's a way to organize numbers, and in the beginning, the basic operations, you're going to kind of be given that information, but what we'll slowly be working to is you basically be given a scenario and you having to create these matrices based on the information at hand. Okay, based on the information at hand. All right, so the first thing we want to always just kind of get our basics down. We want to always start with dimensions. Okay. Anytime you get a matrix, you want to know the dimensions of it. I would start at any point making sure that I have the dimensions down, because adding and subtracting are based on dimensions, multiplying is based on dimensions, so it's good just to have that information. So what would the dimensions of matrix A be? 3 by 3? Everybody agree? Absolutely, right? If you count up, how many we got? We got 1, 2, 3, right? And then we go across 1, 2, 3. It's a 3 by 3. Okay? 3 rows and 3 columns. All right, what is element A22? What would element A22 equal? 5? Does everybody agree? Where would A22 be? What does 22 represent? Second row, second column, right? So my second row is right here. Does everybody agree with that? First row, second row. Second column's right here, so second row, second column would be element 5. So A22 would just equal 5. Okay? All right, what about A31? What about A31? 7? Does everybody agree with 7? Right? 3-1 represents the third row, first column. So row 1, row 2, row 3, column 1, first column will be 7. Remember, rows run left to right. That's the most important thing. These are all rows. You got me? These are all rows. All right, what about A1, 3? What about A1, 3? 3? Does everybody agree? So that would be the first row. So here is the first row, right? And first column would be 3. All right, what about A3, 2? What would A3, 2?
Okay, so it's
8. Everybody agree?
Yeah.
All right, so row 3, so we're on the third row. Column 2 would be 8. All right, so remember, rows are left to right. All of these, row, rows. That's row 1, row 2, row 3, column 1, column 2, column 3. Okay, you got to make sure you understand the whole row by column idea. All right, any questions about that? All right, so that's basic general matrix information that you're going to have to be able to answer. Okay, it's very simple. We can give you a 10 by 10 matrix and give you 100 questions, right? 10 by 10 would have 100 elements. So plenty of stuff there. Everybody got me on that? All right, let's move on to matrix addition and subtraction. Number one thing, if you don't understand this concept, you won't be able to do a single problem. In order to add or subtract, the matrices must have the exact same dimensions. Okay? That is a must. If their dimensions are not the same, you cannot add them and subtract them. So you cannot subtract or add a 2 by 2 to a 3 by 2. Okay? Their number of rows and the number of columns must be equal in both matrices in order for you to add and subtract. Okay? Once you've got step 1 down, once you determine if they're the same, I move on to step 2. If they're not the same, the answer is undefined. It's that simple. Okay? If their elements, if their rows and columns are not the same, it's undefined. If they are the same, I'll move to number 2. Okay? And number 2 is just add or subtract whatever the problem is. Corresponding elements. All that means is if my dimensions are the same, I'll add whatever's in the first row, first column to whatever's in the first row, first column. I'll add whatever's next, right? I'll add A11 and B11. I'll add A12 and B12. Okay? Very simple stuff. So let's take a look at an example. Let's start basic. So let's say we got 1, 3, 5, 7. So that's matrix A plus matrix B, 2, 4, 6, 8. All right, so the first thing we're going to do when we have to add and subtract is we're going to start with step 1. Do I have the same dimensions? So we're going to label each one. So matrix A, what are the dimensions of matrix A? 2 by 2, right? All right, what are the dimensions of matrix B? 2 by 2. Are those the same? Yes. Okay. Yes, so that means we can add them. Now, if you add a 2 by 2 to a 2 by 2, what do you think your answer is going to be? A 2 by 2, right? It's a 2 by 2. Exact same dimensions. When you add or subtract, everything's going to have the exact same dimensions. So if we add a 2 by 2 to a 2 by 2, we should get a 2 by 2. Okay? Now add the corresponding elements. This is the simplest stuff, okay? Now, it's so simple. I know how y'all like to try to make things more difficult. You can't make this more difficult, okay? You add the first element to the first element. So we're going to do 1 plus 2. 1 plus 2 is 3, right? Now, I don't really care how you go about it. You know, if you want to be, you know, whatever, and start down here next, whatever, okay? Just know you got to add the corresponding parts. So I'm going to move over here to this one. So 3 plus 4 is 7, right? Then we'll do 5 plus 6 is 11, and 7 plus 8 is 15. And that's your answer. I know it's my answer because it's a 2 by 2. Okay? Any questions? Some basic stuff here. Okay, basic stuff here. All right, let's move on. Let's try to get a little bit harder. We're going to subtract now. Woo! All right, so here's our two matrices. That's going to be to subtract, denoted by that subtraction sign. All right, what is the first thing we have to do? We got to check our dimensions, okay? So remember, to me, the easiest way, count. So I've got 1, 2, 1, 2, 3, so that is a 2 by 3, right? Everybody agree with that? Count over here. And we get a 2 by 3, right? So can we subtract them? Yes, because they're the same. What are the dimensions of my new matrix going to be? A 2 by 3, right? Remember, when you add and subtract, everything's going to be the same. So, like, to help yourself out, especially early on, like, you know that it's going to be a 2 by 3. Go ahead and put your blanks there, okay? Because, I mean, let's be honest, this stuff is easy, which means that you're probably going to try to blow through it, okay, and not take your time, which means mistakes can happen. But if I have kind of a template to what should be filled out, if I do screw up, I can kind of look and I can see that, okay? All right, so this is the only difficult thing about it. Subtraction, okay? I'm not a fan of subtraction, all right? I'm just not a big fan of it because it's very easy to screw up. So one thing that I will do is I would treat this like a -1 and multiply that entire matrix by -1. When you do that, when you distribute that negative, your problem becomes addition. Does everybody understand that? When you distribute a negative, your problem turns into an addition problem. So really what I can do is I can multiply everything in here by -1, which means just change all the signs, and then I can make my problem an addition problem. That's one method, okay? The other method is just to subtract it. So let's just stick with subtraction. So we're going to start here. So 1 corresponds with what element in the other matrix? 3. So 1 minus 3. That's where you got to be careful, okay? Because some people just look, especially when you have two negatives, okay? So we're going to start here. 1 minus 3 is -2. Everybody agree with that? Yep. I hope so. Okay? All right. 2 minus -1. This is where you got to be careful. Okay? Because now we've got 2 minus -1. Two negatives make a positive. So that's really 2 plus 1, which is 3. All right. You fill in the rest. Okay? You fill in the rest. All right, is this what we're getting? Yes? I would hope so. Okay. Don't let, make sure you understand signs. Okay, this is -2 minus 7. That's going to be -9. Okay. To me, it's always easier to distribute the negative. Because if you change the signs here, then I know that's -7, but I have -2 plus -7. It's more obvious for me. Okay. So that's one method that I like to use, is to distribute that negative, change all the signs, and then make it an addition problem. Just because I like adding more than I like subtracting. All right, any questions? We give you one to do on your own. All right, so matrix A. All right, so you go ahead, work on this one on your own. All right, so 2 minus -4 is 2 plus 4, which is 6. 3 minus 10 is -7. 4 minus -3 is 4 plus 3, which is +7. -1 minus 2 is -3. 2 minus 1 is 1. And 7 minus 4 is 3. Everybody get that? Everybody good with that? Okay? All right. All right, the only way we can make these difficult, okay? The only way we can make these difficult is when we start putting letters into the problem. Okay? So the only way we can make these problems difficult is to put letters in there. But if you recall from Algebra 1 and Algebra 2, we can only combine like terms, right? So that means they must have the same letter and the same degree for me to be able to add and subtract them. So they got to have the same exponent and they have to be the same letter. And if they're not the same letter and the same exponent, then all I do is just combine them together with whatever sign I'm asked to do, okay? So if we add these two things, which we can, we have a 2 by 2 and a 2 by 2. So that tells me that we are able to add these two things. Okay, we have a 2 by 2 and a 2 by 2. So we're going to do the same thing. So I have x plus 2x. So we have the same letter, right? We have the same exponent, so we can add. I have 1x, I'm adding 2x's to that. So that would be 3x, right? All right. The next one is 3 plus y. Are those the same thing? No. So you can't say the answer is 3y. If they're not the same, all you can do is combine them with whatever sign. So if that's 3 plus y, then that's 3 plus y. All right, we have y plus 2y. Now those two have the same letter and the same exponent, right? So we can combine those two. Those are like terms. So y plus 2y is 3y. All right, now I have 2 plus negative x, right? So those are not the same. They don't have the same letter. They definitely don't have the same exponent. So 2 plus negative x, what would that be? What am I going to write? 2 minus x, right? Because that negative will always overtake a positive, right? Do not write 2 plus negative x. Okay, don't do that. That's 2 minus x. All right, it's 2 minus x. And that's as difficult as these problems can get. That right there. So if you can understand that, there shouldn't be an addition or subtraction problem that trips you up. Any questions about addition or subtraction? Everybody good on that? All right. Last thing we're going to cover today, scalar multiplication. All right, when you hear the word scalar, what does that make you think of? You hear the word scalar? A scale. Very good. Okay? And when you scale something, what does that mean? If you scale something, what does that mean? Weigh it. Weigh it. Okay, what else?
Measure.
Measure.
Getting it to the same size.
Getting it like proportionally to the same size, right? Like anytime you build something, okay? Like if you made like a model house, you know, based off a real house, you would have to scale that, right? You know, like you've heard things like action figures are 1/16 scale of the person they're representing, right? That scale just means that we're kind of resizing it, we're proportioning it, okay? Now when you proportion something, that requires you to multiply, okay? So when we proportion something, that means we're going to multiply. When you multiply, that means we're going to distribute, okay? So all scalar multiplication. Now, scalars are represented by the letter lowercase k for whatever reason. Okay? So lowercase k is what's going to represent a scalar. And that doesn't really matter because technically they can give it multitude of different things. Okay? So when we talk about scalar multiplication, what we're talking about is like lowercase k times a. Right? So that'd be scalar multiplication would tell you the lowercase k, whatever your scalar is, times matrix A. Okay? Times matrix A. All that means is that we're going to distribute whatever lowercase k is to every element in matrix A. So this representation here, the lowercase k a, all that means is that we have scalar k, whatever that number is, or it could be letter, okay, multiplied to matrix A, and we're going to distribute k, whatever that number may be, to everything inside matrix A. So an example would be so k would be 2, our matrix would be A. Alright, so if I have this representation here, all we're going to do is take that 2 and we're going to distribute it everywhere inside the matrix. So we're just going to multiply everything by 2. So our new matrix would be 6, 8, 14, 2, 4, negative 6. Right? And that'd be it. So I'm just multiplying everything by 2. Okay? That's it. It could be a fraction, it could be a number, it could be a letter, it could be whatever. Okay? Anytime you have a scalar, and a scalar is a single number. Okay? A scalar, we're talking about a single number or a single value. Alright? So we'll get into multiplying matrices to each other. That'll be next class, but today all we're going to cover is multiplying by a scalar. Now, you will rarely just get a scalar problem where you say, okay, multiply this by a scalar. What you're going to get is, what you'll see more often is something that looks like this. So let's say we have K equals 3. Matrix A equals 3. Alright, so you'll be given this information, okay? And so this is what your homework will look like, this is what your quizzes will look like, this is what your tests will look like, okay? And basically what you'll get is, let's say, that's what a problem will look like. So number 1 would look like this. So let's talk about what that means. What is that asking me to do? If you were given this problem, what would you do? Multiply A by your scalar, and then subtract B. Remember, multiplication always comes before addition or subtraction, right? You got to go back to your order of operations. So please excuse my dear Aunt Sally, that kind of stuff. Okay? So multiplication always comes before that. So if I were to set this problem up, it would be 3 times matrix A minus matrix B. So the first thing I would do is I would multiply. So we're going to start here. Now, do I have to multiply this 3 to over here? No, you never cross another sign to multiply. Okay? Never. Now, we could distribute that if there were parentheses around both those matrices, but there's not. Okay? So we're going to distribute first. So that's 9, negative 3, 6, and 0, minus negative 1, 2, 3, and 4. We have 2 by 2, so we can be able to subtract those. So that's going to be 9 minus negative 1, which is 9 plus 1, which is 10. Negative 3 minus negative 2 is negative 5. 6 minus 3 is 3, and 0 minus 4 is negative 4. So that would be our final answer. All right, for you, I want you to do this problem. KC plus KA. Alright, so here, it's telling us to multiply both matrices by 3, right? So we multiply matrix C by 3, we get 15, 0, 0, 3. We multiply matrix A by 3, and we get 9, negative 3, 6, and 0. And then we add those two things. 15 plus 9 is 24. 0 plus negative 3 is negative 3. 0 plus 6 is 6. And 3 plus 0 is 3. Any questions? Everybody good with this stuff? Okay. All right, what we're going to do, we're going to log on to Canvas. Make sure you check your number there. Okay, I have it right here. So make sure you get the correct number, put it back in the correct spot. When you finish that, what we're going to work on today is we're going to start on iExcel. Okay, we're going to start on iExcel. You have 3 sections. You have adding and subtracting. You have multiplying by a scalar, and then you have combining it. So we just finished up right there. We get to multiply by a scalar and then add and subtract it. And that's simple stuff. All right, so we're going to make an 80 on those 3 things there. That needs to be completed before next time. Before you leave today, okay? Before you leave today, on Canvas, okay, under Matrix Day 1, and eventually these notes or whatever, they'll be uploaded if you need to go back and watch the notes, okay? But under Day 1 is a exit ticket, okay? Before you leave today, I just want you to go in there and complete this for me, okay? It just basically gives you a chance if there's something you're not sure of, like there's something we've gone over today that you still don't quite understand, you put that right there. If you're good on everything, then don't put it, just put I'm good on everything. Okay, I understand it all. But then there are 2 questions about what we covered today. Okay, so you need to make sure you fill that out as a little exit to. So there are 2 questions about what we covered. Very simple stuff there. All right. So you're logging on to Canvas. Okay, you're working on your 3 iExcel assignments. Those are listed for you in Canvas. All right, which ones you need to work on. You need to do the exit ticket before you leave. Everything needs to be done before next class period. Okay? All right. Fantastic.